Okay, a furniture manufacturer builds tables. The cost for materials and labor to build a kitchen table is $240 and the profit is $160. The cost to build a dining room table is $320 and the profit is $240. Let X be the number of kitchen tables they produce in a month, and let Y be the number of dining room tables produced per month. Write an objective function representing the monthly profit for producing and selling X kitchen tables and Y dining tables. So objective function representing the profit. Okay, so we have to look at the profits. The profit for a kitchen table is $160 and the profit for a dining table is $240. So P, profit of XY, is equal to 160X plus 240Y. So that's the profit function, and that's the function we are going to want to maximize in the problem. But first we have to look at all the constraints and write equations for those, and then graph all those. So the number of each type of table obviously cannot be negative, so X has to be greater than 0, Y has to be greater than 0, and then due to labor and equipment restrictions, the company can build at most 120 kitchen tables, so X is less than or equal to 120. And then company could build at most 90 dining room tables, so Y is less than or equal to 90. And then the company does not want to exceed a monthly cost of $48,000. So the costs, remember, for the kitchen table, it costs $240 per table. And for the dining room table, it's $320 per table. So 240X plus 320Y has to be less than or equal to 48,000. So we have our restraints, we have our objective function, and now we just need to graph all those restraints. Okay, so we're just going to graph these lines. For x equals 0, that's just the y-axis, and we're going to shade to the right of that. And then we have y greater than 0, which is just the x-axis. We're going to shade above the x-axis because you cannot build a negative number of tables. And then x is less than or equal to 120, and so there's that line, and you're going to shade to the left of that. And then y is less than or equal to 90 is right there, so we're going to shade below that line. And then you've got 240x plus 320y is less than or equal to 48,000, and you're going to need to get that in y equals mx plus b form. So we're going to subtract 240x on both sides. So we'll have 320y is less than or equal to negative 240x plus 48,000. And then divide by 320 on both sides. So you're going to have y is less than or equal to negative 3/4 x plus 150. And so we're going to graph that by graphing the y-intercept, which is 150, and then going down 3 and over 4, and it's going to look like that. And we can see that that line is going to intersect the horizontal line where y equals 90 right there at 80, 90, and it's going to intersect the vertical line at 120 right there at 120, 60. And this one is easier to figure out where they intersect because they're giving you a horizontal and a vertical line. If they give you two lines that are slant lines, you're going to have to solve a system of equations to find out where those lines intersect if it's not obvious. So our area of interest is that peach shaded region right there, but we know that the vertices are all we really care about. So we're going to look at those vertices and we're going to try them, each one. We want to find the maximum profit, and so we're going to check each vertex for x and y to see which one gives us the maximum value. So the vertices are, as we said, 80, 90, 120, 60, 120, 0, and over here we have 0, 90. So we know 0, 0 is not going to maximize the profit, so we just won't even acknowledge its existence. So we'll just try each one. If we put 0, 90 into the profit function, P of 0, 90, and that's just going to equal 160 times 0, which is 0 plus 240 times 90. And I'm not going to multiply that out yet. And then P of 80 90 obviously is going to be more than that first one, so I'm just going to cross it out. So 160 times 80 plus 90 for that one, and I'm not going to multiply that out yet either. And then 120 60 is going to be 160 times 120 plus 60 times 240. And then the final one is going to be P of 120, 0, which is obviously going to be less than the one we just did, so I'm not even going to do that. Okay, so we just have those two, and if we punch those into our calculator, 80, 90, 80 kitchen tables and 90 dining tables is what would maximize the profit.